topographic and monitoring, volume controls for mining and civil engineering works. And we also study landslides and rockfalls for mining and for civil engineering purposes. Well, we work in a completely 3D environment, working in cliffs and scarps, in rivers, and we use drones to get 3D data as the base for all our analysis. We also develop this kind of 3D simulation of rockfalls, as well as flooding analysis or this kind of geological risk. Well, today I'm here to talk about the Drone.js web platform, and I will show you how I'm using in order to share the data with our clients. Well, here is the view of the Drone.js website. I will show you two cases. The first one is a mining volume control, and the second one a rockfall analysis. In this case, this is a quarry near Barcelona in Catalonia, and here for sure you can see the first product of a drone flight, is that orthophoto, high resolution orthophotos. And this platform allows you to share high resolution orthophoto with your clients, and your client doesn't need to be able to use a GIS or a very powerful computer. You can check the high resolution of 2-3 centimeters pixel orthophotos, and we can for sure compare, for example, the flight from 2022 and the 2024. For sure you have another option here in the timeline to create different flights, but I like to put directly here. Okay, you can see here the query, how in this west side they excavate, and in the east side they fulfill the query. Okay, the second more useful product from drone flights and photogrammetry or LiDAR data is the digital elevation models. Here we can see we can upload different digital elevation models. In this case we have here the 2024 model, and also we can check the before flight from 2022, where this excavation didn't exist yet. Okay, and we can also upload future design scenarios. For example, in this case is an excavation in this west side, a potential excavation or a mining plan, and also the restoration plan, that is the end of the query when they have to fulfill all the query. Yes. Well, for sure we can upload here also the topographic curves and all the kind of AutoCAD product that we can create. Well, I like to use this thermal option to upload the demo of differences. No? So this is the difference between the digital elevation model or digital terrain model from 2022 and 2024. And I like to do that because I create this demo of differences in GIS software, and I upload here as a thermal map. But I like it because I can move the mouse over the data, and I can see how these purple values mean that they increase, they fulfill the query here with 15 meters, and in the west side they excavate with 20 meters. Here you can, using the hand, the mouse, you can check the values. I think that it's something very useful. And well, we can check all this in 3D view. In this 3D view we can see for sure the point clouds, the digital elevation models, all our data. Okay, this is the digital terrain model with this different map. Okay, we can check it here in a beautiful 3D view, and then we can for example create cross sections. I really like this option also because we can easily check the data and focus on this point. I really like this because you can see here the profile of the 4 digital elevation models that I uploaded to the platform. I have the 2024 profile. I also have the 2022 profile, it's the green one, and also I have the potential excavable plan in this query, that is this purple one. Okay, and also I have the restoration future scenario. And moving the mouse across the profile, I can check the actual altitude. In this part, in the upper right part, I have the values of altitude and also the difference, if plus, minus, how much, plus 16, plus 45, minus 11 meters, So I think that, well, this is a simple tool, but very powerful, that I like very much. Yes. So here also we can use this cross profile tool to do that, and also we can create measurements, and we can select different areas in order to generate here directly in DroneGIS different kind of digital elevations models differences, for example, to a constant altitude or between two digital elevation models. Okay, and another beautiful point is that you can check here. Yes, I know that you can do it in timelines, but I like it to directly change here the digital elevation model and the orthophoto. So now I'm checking the same difference volume, but looking to the past or to the present. So in this way, I really like this application in order to share the data from query. Well, if you want, we can check another case. This is a case of rock falls in a highway. This is a natural cliff, okay, near a highway in the north of Spain. And here the problem that we have is that there are rock falls that reach the highway. Okay, so let's for sure we can check this beautiful 3D point cloud that we can get with Mavic 3 Enterprise with RTK, or Mavic with Matrice 315 RTK with a P1 camera, or from LiDAR, or another kind of tools using photogrammetric reconstruction or digital or LiDAR tools. In this way, we can get extra high quality point clouds of a cliff, and we can use all this data in order to characterize the joint patterns of this rock massive, and also to identify the potential unstable volumes. And we can carry out stability analysis, we can develop rockfall simulations, we can analyze the stability and the risk of this area. Well, the point cloud can be plotted, as you know for sure, in terms of height, yes, or with the RGB, with the natural color, or by classification. Well, here the classification, it's useful because we can see the vegetation, and also in these purple points that are points that are in overhang. Overhang, it means that these points will never be well correctly described using a digital elevation models, because in the same planimetric point you cannot represent two different heights. So you need to use in a full 3D environment like point clouds. We can use these beautiful point clouds, for example, to assess the parts of the scarp that are susceptible to produce rockfalls. Okay, this is more steepened part of the rockfalls, the overhangs and the non-overhangs areas. And we can also develop this kind of 3D rockfall simulations, and we can also can study the fragmentation, the breakage of the blocks or not. Okay, so based on these 3D simulations of our rockfalls cases, we can create different kind of maps. These maps can be well represented here. Now I am showing the digital elevation model and the orthophoto. For sure, here we have a very beautiful orthophoto and digital elevation model, and also we can use this thermal option to plot different kind of maps. Well, we can go also to the 2D view to check all these maps. And for example, this is the map of probability of reach of blocks of 0.5 cubic meters from source areas. We have this source area, that are the susceptibility points that may generate potential rockfalls. And then we have this kind of maps of probability to reach the highway. There are maps based on different volumes of rockfall, well, at 0.5, 1 cubic meter, 5 cubic meters, 10 cubic meters. Then we have maps of height, alturas, height of this kind of jumps of the rocks. This is the distance between the trajectory of the rock and the terrain. We have also these heights for all these volumes. We have also the energies. This is the impact energy of the block. And all this information is very useful for us in order to design different kind of mitigation measures, like could be put here a dynamic barrier in order to stop the blocks. And then we can combine the information with their trajectories, the height, and the energy in order to create this kind of thematic maps, where in the green areas it will be optimal in order to install a dynamic barrier of, for example, 4 meters tall of 10,000 kilojoules in order to stop the blocks of 0.5 or 1 cubic meters. And we can show this information in 2D, in all these maps, in these beautiful orthophotos, or also over the digital elevation model, orthophotos, and all this data. No? And then if you want to install here dynamic barriers to mitigate the rockfall risk, you have to put it in these green parts, and if you install it in the red areas, they will be not useful. Maybe here it's very clear, but when you put it in some more complicated areas, these maps are very, very useful. So, well, that's more or less all that I want to show you, and I wish you like this presentation. Thank you very much, and it was a pleasure. Bye.